rods. No, sorry. We should see how long it will be. Maybe 200. We put 200. Or 200, it's too long. No, okay, we try to do this with 150. Okay, this 150, yeah. Okay. I show you how it is better for you to do this, because now what we do, we pre-build this frame for correction, because the amount of rotation here really big. It is maybe quite 40 degrees. For this reason, it's not easy to create the frame and to do acute correction. It's much better in this situation to do it progressively. Okay, we do this. No, sorry, but I prefer that patients are comfortable, and we need to put the anteversion, the femur, because this position of the patient is like this, and we demonstrate the external rotation of the femur. We may change later, but in any case, now we change it during our job probably. Okay. What I want to do, I want to prepare the comfortable frame for the patient, because we pre-build it. Capisco perché questo è un po' storto. Questo. It's a little bit bended, better to use this. Straight rod. Questo qua è troppo piegato. Ok. I want to do this for a better alignment of the frame, because the two systems should be parallel, one to another. And in the femur, we can't use two rings because it's not so comfortable for the patient. For this reason, I prefer to use 5/8. Okay. And this way we position the frame. But now, what we build the system for rotation, and we should do the plus minus the same job, like we did for the translation. Now we use a little bit shorter, maybe 120. We prepare 3 rows with the female, 120. And like you understand what we should do, we should distribute the system for rotation around the circle in the way that will be mechanically much more stable. In this translation should be done radially, because if you do translation, we do it in the same way, anterior and posterior. If we do rotation, it should be done in direction of the circle. It should be tangentially of the rings. We have not so much space here, and what we do, we create this system around the 5 of 8. We use this last hole. Here. One. We put another one with a female. I put it in the middle here. It's not parallel this way. Because it's not easy to understand exactly the same hole of the rings in the 5 of 8. It is easy in a circle, but not easy in the 5 of 8. What we do like this. And for doing this, it's better to put it in the near holes, because the construction of this ring is the same. They are overlapping. I put two rods near. In this way, I understand how it will be parallel. They're overlapping one to another. This. Okay, and now much more parallel. Okay, after that, I start to build my system for translation. Okay, one here, because I use the last hole, because it's this way it will be stable. Okay, here, I use here. And the third one, here with the female.
Anche la quarta la faccio con la
No, three. No, it's enough. Three. Three, it's enough. Okay. Put here. And this system, it's distributed in equal distance, plus minus one to another. And like you see, this is a 3-point that we will use for the translation. We will look at from the above like this. I don't know if may demonstrate from here.
Arriva a questo.
Okay. And this is 3.1 here, one here, and one here. And this is 2 rods, but it's only for realigning the rings. Okay, now we build like with the previous system. We build it slowly, slowly. It's not immediate construction, but may be done with the patient. Okay. Okay, direction of this system. We should remember that which kind of rotation we have. We have rotation and externally. My knee look at the external. The proximal part of the frame should be adapted of the position of the ankle, of the hip joint. Hip joint should be in neutral position. Is this 5 of 8 corresponding of the medial part of the femur. But the distal part of the femur is rotated, and we should imagine that this ring should be rotated slowly, slowly internally. It means that we should create more space here posteriorly to permit the shifting of the rod anteriorly. What I do now, I create, like in previous system, 3 rods. 1, with 2 posts like this. We may use maybe a long rod like a 120 plus minus. It's okay.
Yep.
1. Okay. Here we put or cubes, like I said before, cube or female, the same. One. Oh. No, not. And the precision of this system, to do in this system similar, it is possible to do it only one short rod, but I think it's not system will be not stable, and I prefer to do this translational system, 3 equal rod, the same construction, like this. 1. I do it not symmetrically like you see, because you remember with our system should rotate it internally. I adapt this here. Short bolt, I need 10 millimeters. 1 washer for connection. One 10 millimeters, okay. Okay, 1. 1 is done, okay. This rotated there. Now we do another one. It should be tangential because they occupy the space. Okay. We use one male here. Another male here. Maybe now we may remove one rod. Just give me the problem. This was an only temporary rod for keeping parallel. I use now this one. I put 120 rod, and this maybe I use a female or only for demonstration of the possibilities. Okay, like this. Female here. Another one. Okay, you need to have a little bit of patience, like your patient. Touch this. We have another space now. Bit longer. Okay. Okay, this way adapted better for this rod. It's not enough again. Okay, we do this. This is a classical Ilizarov way to do this, and it's an elaborative system, but it's functional, and you may do this without a computer. Okay, we attach here, here. Okay. Now it's quite done. Small bolt. Okay, this is a second rod. Okay, you see? second, and after that we should put the third one. Okay, like we understand it, continue control this like this. Just go inside, and now another system here. The same rod. Opla. Okay, 2 male posts.
We have two holes.
This. Okay, like this. I put here. It's just a little bit few space. Okay, we put here. Put like this. Because we need to control it, it should be tangential. And this way maybe we do it a little bit longer, 150. Because I find here this bolt in the middle, and for this reason I should change. And I do like this. We use washer maybe for shifting better, easier. This washer here. Okay. Build this. And now I control that should be plus minus 100 degrees, 120 degrees one to another, because it should rotate tangentially. I put here, and now I put another male, or if I may use the female, the same. Like this. Small bolt, 10 millimeters. And nut. Okay, I hope you see this. Here, our system, this remain a little bit disattached. We are right here. Okay. Okay, perfect. We put this in the washer in the middle. Okay, this is more difficult part of the frame, because the rotation is too big. We should create it good in this. Now I don't know if you see this. I think you see. This is a system with 3 rods. They don't do translation, but they permits me to do rotation because they distributed all around the circle, proximal distal circle of the femur. And now I think for you, for everybody, to build this frame like this is better than build it on the patient, because it's a little bit elaborative system, and because we need to adapt the position of the wires and the half pin for this kind of correction. Okay, I put the patient in the right position, supine, knee rotated externally. Before we should put this inside. Put it inside like this. No. It will be easy to do differently like we did it before. We fix the frame and it works with this system like this. Okay. Okay, in this way we position the frame and the femur inside. Okay, like this. Okay, now we should put the femur inside. For the correction of the rotation, it's not always easy to position the frame because the problem of this correction, the bone should be in the middle of the circle. We can't put it anteriorly because in this way, if you do this kind of movement, you will achieve a translation. It should be positioned in the center. Obviously, soft tissue posterior is much bigger. For this reason, we are constrict like I did here. I put the big ring. You can't use a small amount of ring. I use here 180, but maybe in real life it's better to put 200 or 220 because the volume of the soft tissue is much bigger in real life than here. Okay, and we start to put in the wires. Like I said, we look into the proximal femur. Obviously, now we may manipulate with the patient for putting in a comfortable position of the knee. I'll start rotate the patient, rotate the leg internally in the way that my patella is the in zenith. Okay, my assistant help me. Okay, I do this, maybe like this. Oops, the center. Okay, we do like this. Okay, we cut the tip. In this model, the rotation, the fragment is in the middle of mid shaft of the femur. But if you have a rotation deformity mid shaft or a little bit proximal, it's not obligatory to do osteotomy at the same level, because the osteotomy may be done more distally in the epiphyseal area because it's regenerated easier, and it is because it's not important the level of osteotomy, because the femur you may consider like a tube. In any level you cut, the correction of the rotation have the same functional result. Okay, I put the femur in the middle, plus minus, like this, maybe like this. Okay. I'm more comfortable to tension there. I put the wire here. Okay. Okay, tensioner. Because now the difficult part we did before surgery. The surgery it became standard. You only should to create the stable frame, fixing the distal femur like we did before. Okay, yeah, the femur remains in the middle. To realign it easier, what we do, now we fix the proximal part of the femur. We use the post, maybe 3 hole cube. One here, like this. Here, important things, remember that the proximal part of the femur and the distribution of soft tissue, you should do adaptation of the soft tissue in the neutral position, because now you see the femur is a distal part, supine, the patella is up. But when I put the half pin and the wires, or any case in the proximal part, I should rotate the patient in the physiological position of the hip joint. I should rotate the leg like this, going up, yes, anteversion of the femur. And in this way, I should put my half pin here. And like you see now, my cube is too posterior. Better I change it. What you do, because this way you distribute the soft tissue muscles in the physiological position, because after rotation it should be completely different. What I do, I should keep the skin a little bit posterior, because when I do rotation, I should have a reserve of the skin between two systems. Okay, I put here and just a little bit posterior. I don't touch the quadriceps muscle. Put here. I put the half pin above the fracture. The bone is the middle. Short bolt. Okay, adapt it. Good. Okay, let's realign it in the middle. Obviously it's not enough. We continue it here. We put another cube again here. Or maybe we put this system with oblique half pin. And this is functional system for an incline, for stabilization of the proximal part. We'll do like this. It's okay here. Yes, you should always thinking about really good stable frame, proximal and distal part every time. I do this oblique way. Perfect. Stabilize it. stabilize here. This angle, it should be blocked. The self-fixation in the bolt, and I need to rotate only the nut. Oops. Not stable. Okay. Thank you. Fix again. Okay, fix here. Fixed here and here. Good stabilization. In any case, it's not enough. Better to put another one. I do more because the proximal part should be fixed stable. Okay. Okay, one small bolt. Okay, short bolt. Fix it again. Okay, finally, now the proximal part is stable. We should do again the distal part. I a little bit rotated the patient again. Yes. And we put another half pin here. One half pin. Yes, I put the cube. 2 holes here maybe. Yeah, this should be put in posteriorly. Short bolt. Like I said, you see that now I adapt the position of the half pin because of my construction. It's not so easy to adapt. It's a little bit bulky, and I adjust this like this. Okay. I put the half pin here. It is posterior lateral. One. Okay, because this small bolt, we use it frequently, we tight so much and they consume it a little bit. It's normal. They are disposable. Okay, the bone in the middle, fix it. Fix half pin like this. Okay, and I think I put another one from the medial part. Okay, what we use, 1 cube hole maybe, or I put here. It's not important where, important to find the space to put it. Not here. Okay, we do this. Giorgio, nessuno fa le foto. Okay, we do like this. Okay, thank you. Okay, this is like in the stent, it's only major stabilization of the frame. It's about of you, how you want to stabilize. Important thing that all these fragments should be really stable, because it's a big amount of correction we should do. Another thing that there is a long leverage arm of each fragment that we should correct here. Okay? Practically now we build the frame. If you want to do more stabilization, it depends of you. You may add here another arch, maybe the proximal, because the proximal part should be really stable. In the heavy patient, it's not enough 3/2 pin. Maybe you need to do another 1/2 pin. You need to put another small arch here, attach here, and to stabilize the proximal part of the femur. But for this case, it's enough, it's stable enough. I remove the patient from the table. And now we see the construction again, how it is. You see if we fix it with the distal part of the femur with the 1/2 pin, it is inclined like this. This 2 1/2 pin posterior, one from medial side, one from lateral side. And we'll see here this system, rotational system for correction of rotational deformity. And what we do like our job like the previous case. We remove the plate, we destabilize the fracture, or we do osteotomy if it is chronic case. We remove these screws. Obviously, this system it is not so, I think, not so perfect, because you should respect many parameters. The center of the femur should be in this, exactly in the middle of the ring. It's not easy to realign all rods that is tangential. Another thing that the tension of the muscle during correction may create another dislocation. For this, you can't pretend that your correction should be perfect in the beginning. But you know this, our translation system, when we change the direction of the translation, we may achieve realign it after rotation. Much more difficult to correct the rotational deformity. In translation, we may adjust later. Now what we do, if we want to explain you how the patient do rotation. We have a plaster, okay, that I use for the medication, but we use this similar kind of stuff in a clinic. We take the plaster like this. Not this plaster, but how some kind of, how to say, rotolo. The leukoplast. Okay, we do this. And I teach the patient how to turn the nut. What I do, I put the plaster here, or here in the middle, on this female, like this, or better here that it don't disturb her. Okay. After that, I use some kind of marker or pen. I need the pen. Somebody have a pen? No? Or some? I will look it for this one a second. Okay, I have one. Thank you. Okay. And I put here the arrow like this. And other things that I use nail polish, because I should put the color on the nut that should be rotated. I put the nail polish, but I don't have it today. And this permits the patient to do this kind of correction progressively. What he do? He release the nut opposite side when there is a plaster here with the wrench, and start rotate this nut that where I put my plaster like this. Okay, slowly. He distance it. Okay, like this. This will be done one rod. Obviously, it will be done simultaneously to another rod. It is done simultaneously to another rod. And like you imagine, our femur should be rotated slowly. Huh? No, the patient, how did we do this procedure? That we do surgery, operation room, we do osteotomy, and the patient start this correction after minimum 5 days. Depends of this placement of the deformity, but the patient start this correction not immediately, after plus minus 5 days. It should be done progressively, 1 millimeter a day, or if there's too big ring in the amount of correction, maybe it will be faster, maybe 2 millimeters a day or 3 millimeters a day. It depends of the construction of your frame. 1 millimeter is a little bit few. Allora. Okay, we continue the rotation. Okay. Sorry that I didn't remove this temporary rod. I should remove it. If not, it will be blocked everything. Okay. Okay. And now we continue. Correction. Correction. Yes, one rod to help to another. One works, and another do it faster. Okay, like this. Okay, we go forward, we go. Now we'll see if our rotation is good enough or not. Okay, now we oriented. Remember how it was before? Now you see if you put the femur in good anteversion, we have again rotation. And what we do, we continue. Obviously, this was exaggerated rotation here. In real life, maybe it's not so big. Hmm?
This is the normal rotation.
Ah, okay. Oh, there is a mark. Okay. Now we'll see. We continue it again. I may say that big amount of rotation like this, it's not easy to correct with the hexapod system, because hexapod permits you to do this, but maybe one step it will be difficult to do. Okay, a little bit more. We did really big amount of correction. Again. We continue this job. Okay, we continue it. Like this. Again. We have our mark for this. Just a little bit more. Okay. Just a little bit more. We did a big amount of length. Like you see, I do practically shifting on the road, on this horizontal road, quite 8 centimeters, I think, maybe more, to achieve this translation, because it was really big. Oops. Practically. We are quite finished. Now we'll realize how it is. Okay. And now we'll see how the position, because our marks are quite finished. We'll look at clinically. Now you look at clinically, and you see that there's just a little bit of, again, of the rotation, but it's quite finished, because it was really big amount of rotation, and we did a really big rotation. Like you imagine, it was here, from here to here, it is a minimum 60 degrees of rotation. I don't think in your real life you may find the 60 degrees of rotation too big, but it's only for clinical exam. In any case, we did the 60 degrees of rotation, and if you are not satisfied, because you see this mark is just a little bit not overlapping, and we are not finished, we are not satisfied of this, what I do, I made to recharge my system again. What I do, I maintain the distance here. I put one rod for stabilization. Okay. And what I do, I change the position of this one. I recharge my rod here. I return it back a little bit. It's not so difficult. Maybe I return it quite here in the middle. Okay. Here I don't have space. I need to put a plate. I do like this. I realign it here. Okay. Here we put a plate. Small, we have the plate before, we have it here. 3-hole plate, we use it in the previous one. Okay, now we look it again. We have a different length of the plane. We use 3-hole plane, 2-hole plane, depends of the distance. Okay, it is good for me. I attach it here. Here. Okay. I change one, I recharge it, like a battery of your cellular phone, the same. You charge it. Here, I take another rod. There's a temporary fixation. I can't lose my position here. I put another rod, maintain the distance, because there is a big tension here. And I charge another one. I don't need too much, maybe I change 2 holes here. I recharge the cube. Like this. Okay, like this. Okay, now we have another one, which we change here. I remove from here. I recharge my system translation. Touch here, I tie this. And put more rod here. Okay. It's not so difficult to do this. You don't need to stay a computer. Only working with the wrenches, like this, like this. Okay. And now we recharge it. I remove this temporary rod because we don't need more. This is only for temporary fixation. Another one here. Okay, I show you again. It was a mark of original position. Where is it? Here. Okay. You see, this is that's remain for correction because it is two lines. One from distal fragment and another one from the proximal here. Okay. Do you see it? Yes, you see. Okay. This is again the rest of the deformity that we have. But we want to treat our patient definitively. And what we do, we charge it and we continue the correction. Like this. Like this. Like this. You'll see? Oh. We're quite over corrected. Okay, what we have here. We need to correct it simultaneously because if you don't do it symmetrically, obviously you may achieve the translation. If you do it symmetrically, it's better. This, I want to put it in good position perfectly. This way, ring goes down. But in any case, now I don't rotate it exactly in the symmetrical way, but like you see here now, okay, here, it is completely aligned with two lines, and the rotation deformity has disappeared. You see? This is a line, this is overlapping. We did a perfect correction. If you have a little bit of translation or something, it is not my fault, but it's a bond like this. You see, and now we finished. We correct any rotation. Obviously, if you need to do some other things, or correction of varus, valgus, and anything, it may be done, but you should change the the hinges, because you can't do now the correction of varus valgus. You have only one rod here that may permit you. If you want to correct varus valgus here, you need to change the position of posterior. One of these put posterior, and one pushing rod here, and this hinge it will be in the create an axis of rotation that goes from posterior to anterior, and you may correct varus valgus in this way. Okay, but our aim was to correct the rotation deformity. And now, if you look to the patient, you see like this is anteversion of the femur, correct way, and the patella oriented exactly anteriorly. We finished.